In this video, in the CloudVision Getting Started series, I'm going to walk you through the initial device configuration and applying an EOS image to the new system. With the device already onboarded into CloudVision, having completed the ZTP process, the device sits in the undefined container ready to be provisioned. First though, we are going to create a new image bundle which we can assign to the new device. Images can be either uploaded from the local machine or downloaded directly from arista.com. To enable this, the user needs to specify an authentication token in the compliance settings page. This token is used to permit access to automated downloads of the alert base for compliance management, as well as image downloads. The token can be found in your arista.com profile. When I select Download Images, I'm presented with a list of all the images available on the Software Downloads page. I can filter this using the search field. Images available include EOS releases as well as extensions such as the Streaming Telemetry agent. With the images we require now available in our image repository, I can create a new image bundle and assign the desired EOS image and any extensions I may wish to deploy onto my network. Here we will include the newly downloaded 4.27.0f release and the latest Streaming Telemetry agent already available in our image repository. Now let's take a look at the container hierarchy. We currently have a campus and DC deployment managed by this CloudVision instance. The switch we are adding is a new campus switch on a new floor within an existing building. The container structure allows us to logically group devices to assign configuration and image bundles. Here we are assigning that new image bundle to the new container. The result of this action is that any devices placed within this container will inherit the image bundle assigned. So let's add the new device to this container. This interface allows us to select one or more devices ready to be provisioned into the destination container. With the device now in the container, we are going to manage the configuration for the device. Configlets are snippets of code that can be assigned to containers or devices. Here, the device already has a management configlet assigned, which was inherited from a container above. This is a good example of creating a configlet with common configuration that can be defined once and applied across many devices. A device though has a device-specific configuration. To do that, I have defined a simple base config and assigned it to the device, which features the hostname and management IP address. This information is statically defined, though I could have dynamically created this config with a configlet builder which could retrieve information from an external source such as an IPAM. The validate process takes the collection of configlets assigned to the device and compiles a design configuration. This is compared against the current running config and the diff is shown for review. A few things to highlight here. You'll note the totals at the top. Total lines is a count of all matching and non-matching lines in the design configuration panel. New lines, shown in green, is config that is being proposed in the design configuration and does not currently exist on the device. Mismatched lines indicate lines that have a command both included in the design configuration and also currently exist in the running config on the device. However, mismatched in terms of options configured for that command. In the example here, the daemon terminator exec command has different values for the same command, hence the mismatch. The two reconcile lines, in red, highlight config that is currently running on the device but has not been included in the design configuration. We have the opportunity in the validate process to reconcile the mismatched or to reconcile lines in a special reconcile configlet in order to capture those differences. In the case of onboarding a new device for the first time, we've decided that these default commands included in the current running config are not required in our planned configuration. Hence, we will ignore these for the provisioning of the device. Also note that you can click on the number totals to jump to the first instance of the colored lines, then use the up and down arrows to proceed through lines of that color. We save the proposed changes, and this creates a task ready for execution through the change control process. The change control process allows us to stage the ordering of the change and the option to add additional tasks and actions. We can give the change control a name. Perhaps we're referencing a change ticket number or some other descriptive title. We review the planned change, which again provides a diff of the design configuration versus the current running config on the devices. The change also highlights any software changes that have been proposed. Here you can see that our new image bundle will be deployed as part of the provisioning process. Also note the indicator to show that the device will go through a reboot as part of the upgrade process. If we were instead just updating an extension and maintaining the same EOS release, we would be able to execute an extension upgrade without the need to reboot the device. We will execute the change immediately rather than scheduling for later. From here, the device will proceed through the upgrade and load with the new EOS image and new running configuration. At this point, the device has been provisioned into CloudVision and is ready for further provisioning actions, such as through CloudVision Studios, which will be covered in a later video. Thank you for watching.